Hi, welcome back. In this last video, we're going to apply our two theorems, our right triangle leg theorem and our right triangle altitude theorem, to working with these triangles. Okay, so they both have their altitudes drawn in. I just need to figure out which theorem I need to use. Okay, now on this one, I know my altitude, and I'm trying to find the whole hypotenuse. Okay, it would be tempting on this one to say, well, I want to know the whole hypotenuse, so I want to use the theorem that has the word hypotenuse in it. The problem with that is I need the leg for that, and I don't have either leg to go with this hypotenuse. So I do have the altitude, and my altitude will allow me to work with these two parts. If I can find this second part, I can add these two together, and I'll know my whole value for x. So I could think of, I know I'm trying to find x, but if I think of this side as y, and if I can find y, then I can add the 8 and the y together, and that will give me the whole x. Okay? So I'm actually going to be working with this altitude, and I'm going to use this altitude formula. Okay? That says the altitude is the geometric mean between the two parts of the hypotenuse. So my altitude goes here and here. And it's the geometric mean between the two parts, part 1 and part 2 of the hypotenuse. And it doesn't matter which one you call part 1 and part 2. I could say this is 1 and this is 2, or I could say this is 1 and this is 2, because you're just going to end up multiplying them together when you cross multiply. Okay? So let's fill this in. My altitude is the geometric mean, so that means it goes in the bottom and it goes in the top. Okay, my altitude here is 12. This one is my altitude. So that is a 12. It's the geometric mean between the two parts that the hypotenuse is divided into by that altitude, which is 8 and y. So 8 goes in one spot, y goes in the other, and they're interchangeable because either way you're going to multiply them together. Okay? So now I'm going to cross multiply, and I'll get 8 times y, which is 8y, equals 12 times 12, 144. 12 times 12 is 144. And now, this time I don't have to square root, because notice they gave me my geometric mean. I don't end up with anything squared. I need to get rid of that 8, so I just need to divide both sides by 8. I don't have anything squared this time, so there's no square rooting necessary. When I divide by 8, I'm going to get y equals, let me grab my calculator. Get locked on me, hold on. Alright, so I can use a regular calculator on this one. 144 divided by 8 gives me 18. Nice whole number. I don't even have to round on this one. Y equals 18. Okay? All right, let's look at the last one. Okay, so when I look at this last problem, I have my altitude. I know what it is. And then look, I even have my two little parts. So again, I'm going to use this same one that says the altitude is the geometric mean between the two parts, part 1 and part 2, that the hypotenuse is divided into x plus 4 and x. Okay, so now we're just going to fill this in. My altitude is my geometric mean, so that means it goes in the bottom and the top. So my square root of 21 and my square root of 21. And then my two parts, my x plus 4 and my x. And again, it doesn't matter where you put your x plus 4. I could put it in the top or the bottom over here. And then my x, because they're just going to get multiplied together. Okay? Now, here's kind of the tricky part. When I do that square root of 21 times the square root of 21, when I put that in my calculator, if I do 21 and I hit my square root times, and then I do 21, and I hit my square root. When I hit enter to see what those two are, notice it just gave me back 21. Because when I multiply the square root of 21 times the square root of 21, remember it's 12 times 12, which is 12 squared, 144, right? Or here it was y times y, which was y squared, okay? When you square a square root, right? When I square a square root, my square and my square root cancel. So notice here, when I multiply this to itself, it's like squaring it. So I'm squaring a square root. It just cancels out. And when I multiply these two together, when you square a square root, when you multiply a square root to itself, it cancels out and you just get the 21. Okay? That's going to equal, so now I have to multiply this. And remember, when you have two terms in a numerator or a denominator, you have to put it in parentheses. So I'm really multiplying x times the whole thing, x plus 4. Because that is how we don't forget that we need to distribute this x. So I really end up with 21 equals x times x and x times 4. Okay, now this one has a square in it and it has an x in it. So I'm not going to be able to just square root like I've been doing to get rid of that square. Which means I'm going to have to factor this. In order to factor a square root, it does have to be equal to 0. So to make this equal to 0, I need to subtract this 21 on both sides. Because now, 21 minus 21 is 0. So I'm going to have 0 equals x squared plus 4x minus 21. Okay, that I need to factor. Okay, when we factor, we had a couple of methods that we learned in algebraic reasoning, or definitely in algebra 2. One of them was our x method, okay, where you take your a value, which is 1, and put it under your fraction bar each there. And then you take this negative 21 times that 1, and then you take the 4. And remember, we're looking for values that multiply to negative 21. So negative 21, I like to come off to the right. That's just going to be 1 times 21, where one of them is negative. 2 doesn't go in. 3 times 7, where one of them is negative, right? So negative 3 times 7, or negative 7 times 3. 4, 5, 6. Nope, those are going to be the only value things that multiply, the only factors of 21. Now, what's going to give me a positive 4 when I add them together? When one of these, in order to get a negative 21, one of these has to be negative, right? So let's see. 1 and 21, there's no way to get a 4 out of those two. So it has to be my 3 and 7. If I want to get a positive 4, a plus 4, then the 3 is going to have to be negative, and the 7 is going to have to be positive, so that negative 3 times 7 gives me my negative 21. And negative 3 plus 7 gives me my positive 4. So these are my two numbers that I'm going to put here, negative 3 and 7. Okay? Then you would reduce the fractions, but since they're over 1, we leave them just like this. The number that's in front goes with your x, the number on the bottom goes with your x, and the number that's on top gets added or subtracted on the end. So what that looks like is I'm going to have 1x minus 3 and 1x plus 7. When you have two things that multiply together to make 0, then we know that one of them has to, at least one of them has to be 0. Okay, so my x minus 3 equals 0, or my x plus 7 equals 0. Then we solve those, both of them. So on this one, I'm going to add 3 to both sides. When I do that, I'm going to get x equals 3. And over here, to solve this one, I'm going to subtract 7 on both sides. And I get x equals a negative 7. Now, in Algebra 2, in algebraic reasoning, and in Algebra 1, we were done there. Okay? But in geometry, I have to plug them back in and make sure that they work in the problem. Okay? So if I plug a 3 in, right here, I'm going to get 3 plus 4, which is 7. So from x to w is 7. That's perfectly fine. And then when I plug it in here, I get what? W to z is 3, which is fine. But look what happens when I put the negative 7 in. Negative 7 plus 4 is a negative 3. You can't have a negative segment length, right? You can only have positive values for segment lengths. If I put in this negative 7 here for x, I get a negative 7 here also. You can't have negative values. So that means x minus 7 cannot be an answer to this problem. It has to be x equals 3. Okay? Thank you so much for watching.